because I have a lot I want to talk to you about. Okay, first of all, thanks to Mike for filling in last time. I had the privilege of watching it on YouTube the other day, and he did an excellent job. Need to let him do that more often. Today's the last day. Don't forget to fill in the course evaluations. And I guess I'm not going to continue this course next term, but there will be other courses that will be good. Okay, what are we looking at?
The United States.
Yeah, the United States.
Snow in Texas.
No snow. Okay, there's some clues that sort of stick out to me. One is the South here is all more or less purple, but Florida looks like a sore thumb. And then Utah also is sort of out of place out there in the West. You ready for the review? Okay. Cremation versus burial. So if you're in the brown areas, you're more likely to be cremated. We tend to bury over here in the South. So I thought that was interesting. And of course, in the permafrost up north, you don't bury a whole lot of folks, I guess, in Alaska. Okay, this is the last session, and I'm going to zip through a whole bunch of stuff here. Just one thing after another, partly to just kind of give you a flavor, a taste of some of the things that pertain to mapping, in particular related to technology. And also it's from having to condense essentially two periods into one. So let me go ahead and do it. Now, I'm going to go ahead and go through a lot of it, and then put the slides online so you can download and look at it or examine some of the links a little more carefully if you want to take the time to do that. So Mike last time was talking a little bit about GPS, and I was going to tell you a little bit more about navigation. One thing, out west, if you've traveled out west, every once in a while you run across something like this. See that big arrow? That's right here next to this tank. And there are several of them all over the West, just stuck out. Well, I was curious about that and got to researching. And back right after airplanes were invented, they were flying the mail across the country. And they had difficulty navigating from one place to another. And so these arrows were to help the pilots get around on some of the routes. And so that was one of the things I found interesting. I didn't know that was. Mike last time talked about GPS. I'm not going to get into it anymore. There was one thing, though, I thought I would mention because it's sometimes a misconception when related to GPS. Of course, you have the constellation of satellites flying around. In order to triangulate, or I guess quadrangulate, on a sphere, then you actually need to pinpoint 4 different satellites. And he mentioned this last time. And you can identify your location on the surface of the Earth. And he mentioned last time also the use of the atomic clocks in the satellites. And I've had people ask me, say, well, okay, you're measuring the signal coming from the satellite to your phone, and so doesn't your phone need to be synchronized with an atomic clock as well? Because these differences in the time and a little bit off is going to be so slight that just an ordinary clock, an ordinary timepiece wouldn't do it. And so, do we all carry atomic clocks in our cell phones? Well, we don't. Because what happens is, let's say you have 4 satellites and they're all sending a signal to your phone. What they do is they send a series of electronic beeps, and it's all digital. And what I've tried to do here is illustrate that in the receiving phone down here, you don't have to have an accurate timepiece. All you need to do is measure the difference between the signals that you're getting. So all you have to do, you don't need to tie it to Greenwich Mean Time. All you have to do is be able to tell this difference, and so that little bit of a difference will tell your receiving GPS the distance to the various satellites, and that then can be used to pinpoint your location. So a lot of times that's confusing to people. Think that, well, I have to have an accurate clock in my phone. And GPS also makes use of triangulation among cell towers, not GPS, but your phones do. And so that assists or abets the signal that comes from the satellites. We use this for navigation, of course, find your way around. You can navigate on transit systems, in your car, on foot. Google Maps and Waze are probably the two most common, Apple Maps as well. Google has purchased Waze back in when was it? 63, I think. Not 63, 2013 was when it was. And they did it primarily to keep somebody else from buying Waze. Waze was a better navigational system, and so it's now its features are now incorporated into Google. And so Google has given us these maps, and we can use them on your phone now. You can tell where there's a crash, a speed trap, slow down, construction. All of this, of course, is based on crowdsourcing or feedback from the people driving the cars. Remember the guy pulling the wagon across the bridge with all the phones and fooling Google? All right, Google does a lot of things, Google Earth, Google Maps. They do this imagery, provide that either on your phone or on your computer. Yes, Ellen?
How would that know that there's a speed trap? Because people get stopped.
Yeah, if you noticed, what happens is you drive along, you've got your phone there, and it gives you an option of tapping a button that tells you there's a policeman sitting and waiting for people at that location. So it's all based on crowdsourcing. It's from input by the users. Okay, I thought I would zoom in. This is Tucson. You zoom in, there's an aircraft boneyard there. All of this is satellite imagery, but Google also incorporates remote sensing from aircraft. So they fly aircraft, and it allows you then to develop these three-dimensional views of the ground. You've all seen that. Google Earth is a major feature. If we have time, we'll get to it here later today. A lot of this got started back in the late 80s and 90s with this program, with this internet application called TerraServer. You may have used some of that, and it was revolutionary when it came out. One of the nice things about TerraServer is that it allowed you to download the images and download it with what they call a world file. The world file lets you georeference and locate that image within another image and actually pinpoint locations on the ground. And don't really have time to get into some of that. But that has evolved, of course, into the kinds of things we have on our phones or on our computers today, Google Maps, Apple Maps. And every time I say Google, my phone will beep. So that's why.
Google result.
So I have to be careful. I should have turned it off. Anyway, so these applications provide satellite imagery. And over time, this imagery has gotten better. You notice three-dimensional viewing now. This is Jordan-Hare Stadium. There are a lot of web-based viewers where they make satellite imagery available. And I'll just list and run through several of them. One of them, you can see Zoom Earth, Worldview. I'll show you some of these here in sequence. And I'll put the slides on the web so you can go and take a look. So here's Zoom.Earth, and this is what you look at, and you can identify a particular date or a particular location, and if there's a satellite image available, it will take you and let you look at it. All of this is free. Here's another one, Worldview, Earth Data. These are both from NASA, and you can see the track of the satellites in that pattern. USGS, Geological Survey, also provides these sorts of images. You can download all of this with a lot of extra features. The European version of all of this is called Copernicus. And you can go and here's an image from Copernicus. This is part of the English channel. And of course you can zoom in and get a lot more detail for many of these. Here's another one, Earth ESA. Similarly, this is the one from the Brazilian Space Agency. And so if you access this site, then you'll probably want to go up there and make sure you click on English, unless you speak Portuguese, and then you can identify the image you want. NOAA, the Weather Center, has a lot of imagery of various sorts. All of this is downloadable. Again, all of it for free. Most of it is georeferenced, so you can plug it into an application such as a GIS. So I'll get to talking about just a little bit. Geodetic survey. Here's one that's a commercial site, Maxar, but it does have a lot of good free imagery. And so I listed it as well as some of the other ones that are all also available to the public. USGS, again, here's another one. This is what they call Glovis. And again, you can search for images for just anywhere in the world. And if they have it, they will provide it to you. This one is very interesting to look at and vary the various inputs. It gives you a combination of images as well as maps with a lot of data of different sorts. It's called www.echalk. It comes out of the United Kingdom. NASA, another one. This is one where you build your own. Whirlwind has been around for quite a while, and it's very commonly used. And this is what it looks like, and you can see all the different kinds of images and things that you can input, and it will add all of those to the map, and then you can download it and make posters or whatever you want to do with this stuff. I'm sure you've seen Bing. Bing is the Google Map, oops, shouldn't say that, equivalent of for Microsoft. And it has some nice features. It includes mapping, of course, but as well as mapping, imagery. So here's image looking down at the museum where we are right now. And it gives you what they call a bird's eye view. So you can rotate around this, look at the museum from 4 different angles. And most of the applications are able to do this sort of 3-dimensional view of the surface of the Earth now. And so Google Maps has been the one that's been around for a while. I'll talk about this. I'm going to avoid saying the word now. These are some of the applications that the company gives you. These are all essentially available for the public and also related to mapping and spatial analysis and those sorts of things. And a lot more. So one thing to think about is this company has been in the news quite a bit lately. And there is concern that Facebook and Google are manipulating us in various ways. Well, I use these things a lot, but you have to sort of be careful. Here you see one of the headlines. This was in the Washington Post just a couple of months ago. And it's been sued, and they've settled some issues in Europe. And I would say, as with everything else on the internet, just know what you're getting into and sort of proceed with caution. It provides amazing applications, but of course they want something in return, and they will send you advertising specifically targeted to things, places where you are and what you're looking for. And as with anything else in the cyber world, use caution. There's several safety features. You can opt in and out of location sharing, some things like that, for example. So look at the settings and sort of make sure you know what you're doing, and also watch out for your passwords. Authentication. They provide you the option of twofold authentication where you not only put in a password, but you might get something on your phone to sort of confirm that. Get to know the software, who it's communicating with, but if you're too skittish and don't want to use any of this, then you miss out on a lot of good things that they do provide, a lot of benefits. But on the other hand, I think you need to just not jump in whole hog without thinking about it. Here's an interesting site that's worth looking at. It's called Ethical Geo 2019. We've talked about this. I know I've talked with some of you about this in here before. Maps are powerful tools. You can convince a lot of people of a lot of things just by the use of maps. People see maps and they immediately take what they're looking at face value. I just showed you the map of Berry or Cremate. Well, you don't know where I got that map. I could have made it up, and yet most of you, including me, I didn't actually look at the source very well. We just take it for face value that that's telling us the truth. Well, there's an organization out there called Ethical Geo whose purpose is to oversee the use of maps, not sort of the simple map like I showed you earlier in the class, but when we use maps for analysis and when people are distributing commercial applications that make use of geospatial data, then it's an effort to safeguard and to make sure that what you're getting is legitimate as data from valid sources. And so they'll go back and double check and provide warnings if it's not ethically collected or being used in an ethical manner.
Have you ever accessed it and found out that there were spurious sources?
To be honest, I haven't used it I've gone to it on a couple of times when I've been suspicious, and everything I've looked up turned out to be legitimate. But I'm happy it's there. It's sort of like some of these other things. You all probably use Snopes.com to check on things on the internet, and it's just sort of another way of kind of looking out and making sure that what you're looking at is legitimate. All right, well, looking at most of what we look at on our devices or on the computer looks something like this. This is really a combination of imagery as well as mapping features. And so part of this is a satellite image, and the other part are these lines and then the labeling that comes from other sources. Google came out with this street view a few years ago, and so you can also look at the ground in this fashion. They drive around with these little vehicles with cameras up on top, and they're doing a 360 rotation as they drive along and taking pictures, and so you can see things along the way as you go. And they have pretty good coverage of many areas around the planet. And one thing that they have done that you may have noticed is there was some complaints about privacy, and so now they will blank out faces of people walking on the street. Now, if you know what your husband was wearing, then you can probably identify him, but that's at least a step in the right direction. Or if there's something embarrassing, then you can actually contact Google, and they will take it down. And I've known of cases like that. So if you're out sunbathing in the backyard or something, and all of a sudden you're showing up on Street View, then you might want to remove that. You can go down the Grand Canyon, but they did that, and just walk it. Here's a 2016 view map showing all of the areas where the Street View is available. And so you see some areas are not available, large areas in Russia and China. For obvious reasons, the government didn't want you to get in there. And notice that Europe has pretty good coverage, but there was an issue with the company in Europe, and so notice that now Germany is not available in Street View, which was interesting to me. Other areas still are. But it's fun to go down and, travel there. There are various games you can play. It'll show you a picture, and then one of the things you can do is try to guess where you are in the world based on that image. Yeah. Various data sources. I'm not going to go through all of these, but this just shows you where some of the images come from. Some of it is public domain, open source. So last time, for instance, I talked about OpenStreetMap. That's something they use. But other portions of it are commercial or purchased. And other ways they collect data. You can see, I mentioned crowdsourcing a while ago. They also collect data crowdsourcing. So anyway, a lot of this stuff going on. One thing that's been interesting that this company has put on the web is this time-lapse site. And I urge you to go there and take a look at it. Because what they've done is collected images, satellite images from periods of time, sequences over time, and then you can see how things have changed over the period that they show you. And it goes generally from about mid-1980s all the way up to the present. So I'll show you one here. Let's see. Well, that one should be, it's not cycling through, it's the Aero C. And, if it cycles up to the present, then it, and unfortunately this one won't either. But I'll try to post that. I wanted to show you Auburn, Alabama as it changed through the years. Another site that does something similar is this Living Atlas by Esri. And again, the same kind of thing. You can cycle through a whole series of images. I'll talk to you a little more about Google Earth here in just a few minutes, but I want to talk to you now about GIS. And I make it bounce because that's probably the most important development in spatial analysis and studies over the last several decades now. And basically began with, there was an earlier edition of Design with Nature by Ian McHarg. He was an architect, and he published a book called Design with Nature. And in that book, he had overlays. So he had acetate pages with maps and images and things drawn on them. And the idea was that you could put these acetates, you could lay one on top of another, and as you did, it would build up a map with different features for a particular area. And it was innovative, and it was an idea that was then, with the development of computers, brought to the digital world, and so we have the creation of what they call GIS. And here's kind of a historical outline. Now, one of the earliest was the Canada GIS. And the idea is to create layers. So this is the way it works. You have spatially referenced information, maps of all kinds of things, some of the kinds of things that we've talked about in here, but it might include imagery from a satellite, it might include information about the rivers and the waterways and highways and the value of property and land use or anything else you can imagine, sometimes hundreds of different layers added into the analysis. And then you use that to actually query the whole program or the whole system. Here's some of the software that is used for this. These are some of the more important commercial products. GeoMedia has actually changed its name now. But here's the way it works. So here, let's say you have 4 different layers, and that's the term they use, layers. So we have, let's say, county boundaries and hydrology, that would be rivers, the transportation system, and then maybe city limits. And you put all of that together, and you can make a map, but you can also do analysis. So maybe sort of a simplified analysis might be something like, well, I want to locate a store, and I want to have access to a certain number of customers. I need to be within 2 miles of an interstate. I can't afford to pay more than a certain amount of money for a piece of property. And so you would analyze all of that. And then the program would tell you locations that fit the criteria that you input. So you would have these parameters that you would add to the program, and then it would, based on all of that, would give you information that you need then to make decisions. And so it's been very useful and widely applied around the country and really around the whole globe. There are a lot of things that have to be dealt with. So for instance, here's one. This is a clipping problem. So you add a bunch of maps or a bunch of features here of an area, and there's overlap. So one thing you have to do is to get rid of the overlap and turn it all into a continuous area or a continuous layer, spatial layer for analysis. Another thing that a major issue and something that has to be dealt with is that maps and any kind of spatial information comes in a variety of formats. So here I've just copied about 4 different maps of Pensacola, Florida. And you can see they're at different scales, they have different orientations, different projections. And so in order to do a thorough analysis, you have to be able to reference or geo-register all of that stuff. They all have to relate to the same location on the ground in order to put all of this together. And this can be done automatically, again, depending, a lot of times the maps or the spatial information that you have has georeference information built into the files, or you might do it manually. So the first problem is then how do they accurately overlap? Again, they come in different sizes, different scales, and that's a critical issue within GIS. And the whole point then is to make sure that every one of these maps here is tied to an exact location on the ground. So every one of the features can be referenced exactly to a spot on the Earth's surface, a latitude, a longitude coordinate. So it's also possible to manually reference these things. So if you have, here's a part of Google Maps, for example, and here's a map that I have of the same area. This is Miami. But notice that it's a little bit cockeyed, but you can easily tell what the features are. Here are the big interstate systems. You can see them on the image. And so you would, using the software, you would identify common points on both of these images, and it would then adjust. You would probably take more than 2 or 3, and it would adjust that image to fit directly over this image, and it would georeference or register that image. And so that's an important element, an important component of GIS. You have to be able to do that. Many times that information is built into the maps, and there are certain map file formats that have that. So if you've used different formats for images, you know about JPEG and GIF and various other ones. One of them is called a TIFF file, and a GeoTIFF is a TIFF file that has that referencing image within it. For a JPEG, JPG, which is a common image format used on computers, you can associate it with a world file, and it would be a JGW, and it would link things together and georeference that image. Now, don't want to get into this too much, but just be aware that it can be done automatically. Google Earth and Google Maps, they produce files that are called KMZ, KML files. That's simply the compressed version of a KML. KML is, if you know about computer files, it's an XML file with georeferencing location associated with it. So if you export from Google Earth, then that's the kind of file you would deal with. The government now provides most of its images, most of its files. You know, you used to be able to go down to the store and buy a map that showed population or the U.S. topographic maps, USGS. Not so much available anymore. They sell, or they provide, don't sell, they just provide for free. A lot of maps now, but they use what's called GeoPDF. You may have run across that if you've tried to download one of these. It will display as a PDF, but it doesn't have georeferencing information. Okay, I apologize for getting into the weeds. So And there are ways to do all of that. I'm going to skip over some of this. This is a good site to go, and if you ever need geo-referenced USGS, you know, the topographic 7.5-minute quadrangles, the kinds of things that I've been showing. This is a good site to go to and be able to download these geo-referenced images. And so here, for example, I wanted to get that particular area of Miami Beach that I was showing you a while ago. Notice that they provide georeferenced images in a JPEG format, again the Google format, KMZ, GeoTIFFs, and GeoPDFs. And so you can simply import those directly into a program like Google Earth, and it will put it directly as an overlay into the right place. All right, problem number 2. Computers do graphics in 2 ways. One is a raster image, and sometimes referred to as a bitmap. So most of the images you see on a computer or on your phone are raster images. The picture you take with your camera is of that sort. And what that means is if you zoom into it, you get this stuff. It's all pixelated, right? And so that's the way the image is made. It's just little squares are colored different colors, and if you're far away, then it doesn't show up as much. The other way computers make images is by using vector techniques or technology. And so all the lines and the points and the outlines you see on maps are done in this way. And basically, what it does is it creates segments by connecting points with lines. So these are not pixels, these are mathematically determined polygons, points of various sorts. So all of the Tiger files I mentioned are of that sort. They are vector files. So you have points, lines, polygons, points, lines, polygons. And so points, lines are collections of points, polygons is a line, but where the last point is the same as the first point. And so something like this is really a combination. You have the satellite image in the background, but also these vectors laying across the top that refer to the roads and all the other features. Now, all of these things then have spatial references, location. So for in a GIS, it knows exactly where all of these things are on the surface of the Earth. Each feature is located. All of these features on the map or on these layers in the GIS also have what they call attribute data. And that's data about the feature. So that makes points and segments are, that's the spatial data. Other things, though, may be associated with that road. Maybe a highway number, maybe a distance measurement, so value of the house. Anyway, all of this is attribute data. So I illustrate this with an example. So here are some cities for which I have some data. So I have population data, I have crime data, violence, so on. So all of this is all attribute data associated with each one of these locations. So it will link the attribute data to the spatial data. So each one of those cities would have a latitude and longitude coordinate, and then that coordinate would be associated with the data of the attributes. And so it ties this stuff together. That's basically what the GIS does. It's a database that deals with spatial information and links all of these things together. And that allows you then to do analysis. So then you can take this data and you know where it's located, and you can plot it on a map. So that's everything that's going on there. Relational database, if you know the relational database, that's what these things do. There are thousands of applications that make use of GIS. I'll just show you, this is just in the sort of the agriculture section here. and analysis of disease control, real crop yields, productivity, water stress. All of these are applications, ongoing uses of this technology. So here are some things you do with GIS. So one thing you do is watershed analysis. It's important to know where, if rain falls on a particular area, where is it going to end up? Is it going to go west or east? What river does it end up in? That's one. Utility companies use this all the time. You talk to somebody and, the people, Alabama Power, any of them, they have, all of their data is on GIS. The location of the poles, where the wires are, transformers, everything. And so when one goes out, they simply look at a map and they can plug things in. Here's one, wildlife migration. And you can see the lines on the map drawn for, I don't know what wildlife that was, but anyway. Vegetation monitoring, especially using infrared. As Mike said last week, infrared will show healthy vegetation, and so you can monitor that. Related to this is something they call prescription farming, and that's GIS applications used in agriculture. Tractors now come equipped with GPS and GIS, and so by analyzing individual locations within the field, the farmer can know areas that need more water, that need where the soil quality varies from one, where certain organic elements are in demand. And so you have prescription application of fertilizer, pesticides, things of that sort, down to the almost to the square meter, maybe not that small, but anyway, the tractors and the farmer come equipped with this sort of technology, increases crop yield. A lot in marketing and sales, things of that sort. Where are the customers? How far do they have to travel? Distribution of various kinds of commodities and products. Transportation departments use this stuff a lot, of course. This is one where they're doing crash analysis, and you can tell where the problem areas are, where you need a new stoplight or more enforcement, monitoring. So anyway, it can be used for all sorts of things. It's used in two ways. One is to display things, to show things, and the other is for analysis. That's figure out what's going on. So I'll give you a couple of examples of this. So most cities, most counties have some sort of GIS display area or GIS information site that you can go to and click and get a lot of information. Here's the one for Atlanta, Georgia. And you can go to the maps and you can find out all kinds of things about Atlanta. Here's one for LSU. One of the best around is actually Auburn City Maps. And they provide all kinds of information. It's just go to auburnalabama.org.maps or /maps, and it's an interactive site. Actually won an award back in 2012 when they put this together using some of the ARC view information or application programs. So this is what it looks like. Here's one. This is a land use. You have various things you click on to bring things up, and you can show things together. So here's the future land use map. Oh, you can do routing. So if you want to get from one place to another, then the Auburn map will let you do that. Here's sort of the basic layout. It will show you the outline of various buildings, and notice all the things you can click over here. So let's see. Let's just. You can look at this as a map, or you can look at it as imagery. You can go back and look at earlier images of the same area. Here's one that shows all the rivers and lakes. I guess these aren't rivers, creeks. School zones. This is residential land use categories. You can see red would be commercial. These are all the different buildings, I guess. What are this? Is planning layers, zoning layers. These are bike paths of various sorts. And these are fire hydrants. You can click on any one of the parcels of property, and it will tell you information about it, who the owners are, what kind of facility it is. Let's see, I blocked out the owner there. But it gives you, it used to provide some of the tax information. You have to go somewhere else now for that. You can select a large group together and it will give you information about the whole area. It gives you contour lines. Anyway, there are any number of other things that are available. This is all on the Auburn City GIS website. So it can be used then for display. They will also give you free training if you have an interest in doing that. Lee County also has one. Yes?
I was wondering, with this quarry going in and the controversy over that, and you were talking about watersheds and so on,
Yeah.
can they use these to...
Oh, absolutely. I'm
where
sure.
waste would go and
Yeah.
everything?
I'm sure they're already doing it. Yeah, because that's just one of the first steps in any sort of analysis of that sort. You know, where are you taking water from? Where is it going? One thing you want to be careful with water is you don't want to, it's important not to transfer water from one basin to another. I mean, that's something we get into, particularly with the Chattahoochee Valley and all that controversy up in Atlanta. And so even you may be taking water out and let's say for urban use, and then it be treated, you know, the sewage, but you want to make sure it goes back into the same basin instead of being cycled off somewhere else. I'm sure they're using that already. Yeah, civil engineers. I wanted to show you the Lee County version of this, and it's not quite as slick. You go to William Price's website. It's alabamagis.com Lee, and as you would expect, there are sites like this for all the counties, most of the big cities in Alabama. This is what it would look like. Again, you can select an area, you can select individual parcels. And one thing this one does that the Auburn City doesn't do, of course it provides information about Opelika and the rest of Lee County, but it also now will give you the tax assessed value of the land itself and then the improvements on the land. So those are the kinds of things you used to have to go down to the office and look in those big books and find out all of that. Well, it's public record now and it's easily available on the internet. Here's another one. Well, this is Coleman County. I was just going to show you. It's comparable, does the same kind of stuff. And again, available. There's one that's available. It's called Acre View. Now, this is a private corporation, but it does something similar. It will give you, you're familiar with Zillow, which advertises houses for sale and that sort of thing. Well, this is something similar. It will identify properties for sale, and you can click on them and see pictures and that. But also, it will give you information about parcels of land that are not for sale. And it gives you something of an estimate of the market value of that parcel of land, of that property, of the house or of the open land. So that can be useful. I don't know exactly how they get all their information. I guess look at comparables in the neighborhood and things of that sort. But it's something that I just sort of randomly pick one here, and you can you have to. Well, you have to log in to see the details about the property. It does give you value, though. Acre value. I'll have to go back and look at that. All right, one other point I wanted to make about this before I give you a quick break is what you're looking at and all that stuff that I showed you, the fire hydrants, the bike paths, everything else, is really just the tip of the iceberg, because these GIS programs are also used for many other things by government entities. So the city of Auburn, for example, will have things such as where their police patrol routes are, or other sort of confidential information, things that they wouldn't want the public to know. But they're managing all of that behind the scenes, again, using the same kind of data, the same kind of information that you're looking at as the public. But of course, you have to have certain clearance and permissions to get to it. Okay, let's take a quick break, and I'll come back and talk a little bit more about how you might use some of this stuff for analysis. Quick break, because I got more to do, got more to tell you. Let me talk to you a little bit about how you might use GIS for analysis. Let's see here. And again, some of the popular programs, GeoMedia has been, the name has changed to Hexagon. Okay, these two, GRASS and QGIS, are actually free. So if you have any interest in getting into some of this stuff and you want to do it on the cheap, then this last one here, I'll show you a quick application with that one. It will do just about anything that the commercial software will do, and do it just about as well. So, and it's free. So just go to www.qgis.org. And what there is, there's a group of people, committed specialists, who maintain this just sort of out of the goodness of their heart. And I am appreciative of what they do. Okay, a lot of tutorials, a lot of books, a lot of ways of learning all of this stuff. So don't be intimidated, just jump in. A few years ago, I did a sort of a pilot study for our United Methodist Conference, and they were interested in some spatial analysis of areas, how many people lived around churches and how things were changing. Now, United Methodist Church is going through a lot of turmoil today. You've probably heard about it. I'm not going to talk about any of that, but it's divided into conferences. So each one of these areas is what's called a conference. And we are in the Southeast jurisdiction and part of the Alabama-West Florida Conference. And so all our preachers stay within this area. The bishop assigns them. They move about from church to church. And so I was interested in, or they were interested in, trying to understand a little bit about the spatial layout and the potential membership and how patterns were changing and so on. So within this QGIS program, you notice here I've got several layers, different maps and things, all of this geo-referenced in the same area. So here's the transportation grid placed over the area associated with this conference. And also they were interested in which churches fall within which political district, and I guess they wanted to write their representatives or whatever. So you can do that, overlay all of this stuff, do other kinds of overlays. And so the little yellow dots here represent all of the churches, some big, some small, various ones. The pattern here, this is just within Alabama, could have done it Florida as well. The patterning, these are census tract areas. These are areas where the census collects information every 10 years, and then they estimate information in the intervening years. And so the idea was to say within a 15-kilometer area, radius, how many people lived within that area surrounding the church. And you could have used different values, and other kinds of variables. But the idea was to say, well, how many people would we find within the vicinity of that church? And so these are referred to as buffer zones, these little circles. And there you see them on the map, all of those. Another one. And so what we want to do is to combine, is to use the population data available in the census to estimate how many people would be within each one of those circles. So just to use an example here, Walnut Creek Methodist Church in Clanton. Okay, here's a circle, 15 kilometers, and here you see all of the census tract areas within it. So what can you do? Well, you know how many people in these census tracts, and so you take one like that, it's completely contained within the circle, and so you can simply add it to the total population that you're trying to calculate for that buffer zone. There are, and you know the area as well. There are others though, so here's another population tract that fall partly within that circle but partly outside. So then you have to determine, well, what percentage of the total population would be within this area? Well, the GIS program does all of that for you. It calculates the area. You know what the population density is because you know the total area of this census tract and you know what the total population is. And so you can just use what you know about this area and apply the population density and come up with a figure. Basically, you do all of that. I'm going to go into all the details. So here you have, for that particular segment, that was part of Census Tract 606. And I know how many, I guess that's square kilometers, what the population density is, and so you calculate a population. Eventually, you add these things together, so there is, all of these go for Walnut Creek, all that adds up then, and you get a total population within that circle. And so the GIS program allows you to do all of that computation and put it all together, and so for each one of the churches, you can tell how many people live within that, or estimate, I guess, how many people live within that 15 kilometer circle within that area. And so you come up with estimates for all of the churches. Well, what do you do with that? Well, you would, compare attendance, actual attendance, to the total people in the area. Maybe you want to analyze changes over time. If population is increasing, but your church attendance is decreasing, that tells you something about the church and the preacher. And or if it's going the other way, maybe you have an area that's depressed, but the attendance is increasing. So it's a way of analyzing, trying to understand what's going on. Well, did this as a pilot study, and it was all interesting, and they were excited about it. But as it turned out, other events within the church sort of caught up with them, and we didn't go any further. It didn't get into all of this analysis, but it is a way of illustrating what you can do with a GIS in terms of analyzing some of the variables in an area. All right, I wanted to tell you a little bit about Google Earth before we run out of time. And Google Earth is an openly available free program for download. It's not open source. You can't use it commercially without permission. But it is available for anything that we might do. And now, there used to be a version called Earth Pro that was commercial, that cost a lot of money. It's completely free now. A few years ago, they made that completely free. So you now have access to all of the features of Google Earth Pro that were formerly not available. And you can also use it in your browser. You can download it as a separate standalone program, or you can use it in Edge or Chrome or any one of the other browsers. And this is basically what it looks like. You can go to the website. All you have to do is go to, well, I didn't put it on there, but just do a search for Google Earth and you'll find it, download it, set it up, install it. And I would urge you to download the Pro version because that's free and you get many more features. You can look at the moon, you can look at Mars, you can look at the constellations up in the sky, just point things in different directions. All of these wonderful features from taken by telescopes, they're all correctly located in the sky within the constellations. You can dive under the ocean and look at the floor of the ocean and see where see what the underwater topography is. And one thing that you can do is to show terrain, to see things in 3 dimensions. So you can move around in it and the mountains stick up. So there's Mount Everest, and you can fly, and I'll show you some more of this in a minute. Well, how do they do that? It's all done with satellite imagery, or that part at least is. Back in the late 90s, early 2000s, there were some missions, including the shuttle, where they did satellite, the first one was a radar sat, where they did satellite surveys of the Earth. And they used radar. And so they could tell the elevation by the bouncing of the radar back to the satellite. And so they did a radar elevation for every 30 meters on the ground all over the Earth by these continuous passes of satellite. So what that allowed them to do is to create what they called a DEM, Digital Elevation Model. And so you have this wireframe reconstruction of the land surface. All of the features on the surface of the Earth are reconstructed in that way. So then it was a simple matter of taking the satellite pictures and sort of in the computer computationally draping it over this surface. And so that's basically what you're looking at. So there's sort of the DEM elevation model surface. And I use this as an example to show what was done. So you have the surface down below, and just like the clothing laying on the grass here, then all of the satellite pictures then get draped over that surface. So when you look at something like that, it may look like, you know, somebody flying an airplane over a mountain, but it's really a combination of pictures taken straight down and then draped over this radar-created digital elevation model that they use. So it's a very unique, interesting. You can download the DEMs. Google Earth has a little thing you can use to practice driving an airplane, so you pilot and fly, and air simulator, that's what it is, which is a lot of fun. You have all kinds of, it's sort of like a GIS with a bunch of layers that you can click on. One thing you can click on is 3D buildings. Now, the satellite imagery in that 30 meters elevation model is not adequate to show building profiles. So they use a different technique, a different technology for that. 3D, at first in Google Earth, they were creating the buildings, or people were creating them and then providing them to Google using SketchUp. And so here you see, this is in La Paz, Bolivia. You can see a couple of buildings here that stick up. Well, these were created in a drafting program, again, that's freely available, called SketchUp, and then spatially referenced and located on the ground. There's another one, and it's a CAD SketchUp program. It's easy to use. Most anybody can do it. It's very useful if you're doing woodworking, or let's say building furniture, or even if you want to model your house. So I would urge you to take a look at it and download it. And so here's St. Louis, again using some of these SketchUp buildings. But now they've come up with another technology, and basically what they're doing, Google is contracted for aircraft to fly and to photograph the ground in 3 dimensions, or in multiple dimensions. So this is what St. Louis looks like today. So there it was before, and now the 3-dimensional, they have 3 dimensions not only for the buildings, but also for the trees and everything else. Here's Auburn, Alabama, and again you can see the 3-dimensional effect. And it makes use of what's called parallax. Parallax has to do with determining distance by looking at something, looking at the same thing from 2 different perspectives, 2 different points of view. We use it to measure distance to stars, It's how you and I see depth, how we perceive depth with our two eyeballs. And, you know, you've seen these kind of things. If you stare that long enough, you can see the three-dimensional figure. I forget what it was, wasn't it? Can you see it? I think it's a butterfly, does it? Does it jump out? Anyway. Remember the old Viewmaster? We used to look at those again with the same kind of effect. And basically the way it works, all right, I got an old Viewmaster picture here and I thought I'd show you. All right, you look at the two images look similar, but if you look at the difference between this guy, the same guy here in this picture and where he is over here in the other picture, or look at this guy, I guess. Look at the slight difference shift in the position of his head. See the corner of the building here and how it hits his head? Well, that's the thing that allows you to perceive that depth, that third dimension. And so that's what's being used in Google now to create three-dimensional effects for buildings on the ground and trees and everything else. They're flying aircraft and they will combine two pictures or more of the same feature with that parallax conversion, and then they can create three-dimensional effects. And these are areas across the country where that's available. Some of the national parks, all the big cities, including Auburn, all over Europe. So it's not available everywhere, but it is available in a lot of interesting places. So here are some examples. That's in Rome, St. Peter's, London, here's Paris. National Park. This is a simple view of Bryce, and now here's the three-dimensional parallax effect, and you can see it's almost like you're sitting there looking down at it. Yeah, Ellen.
In the afternoon, when I'm driving,
Uh-huh.
there is a time of day when depth perception seems to go away. What's happening then, Sonny?
You're getting tired. I don't know. I don't know that it relates.
It seems like it's something about the light that just...
It might be. If the light is very bright, you know, it might destroy some of the cues you're getting from, because we perceive depth in a lot of different ways. I was a psychology major in college, so I know what I'm talking about. And one of them is this parallax, but we also get clues from, you know, the color. If you look at blue and you see blue mountains, that tells you they're a little further away, you know, things like that. So, you know, it'd be interesting to find out why that's happening to you, but I'm not sure it's related to
Yeah,
this.
I think it's just me. I think, you know, probably if we did
Is everybody driving?
a map of when wrecks...
That would be a good project, yeah. Okay, so here you are. You see some of the areas in Alabama, features. That's the president's house. And, you know, different views. I'm really sorry I didn't get that time lapse to work for you. All right, there's something that you can get a hold of. Now you have to write Google and request permission and then create a little logon, but it's simple. They'll provide it to anybody. And it's a 3D visualization assistant. It's a little program that works on your computer. I'll show you what you can do with it. So it will essentially fly you around things. Now this is all based on the stuff that I've been talking about. You know, it looks like you're just in an airplane and you decided to fly, but you can create the path of the track or anything you want to do. So that's, of course, Devil's Tower in Wyoming. I'll show you how it works. Here's a program. So what you do is you can change the orientation of the imaginary camera. You can change the track you're flying on. You can go up and down, do all of that, and control all of that within this program. So here's one that I did for Auburn, and we'll start at the stadium and essentially fly over here to the museum, and again twist around and zoom into it. Okay, and so then I ran it and I captured everything that was going on my screen as it was doing this. So here's the operation of the program. You set these control points, all kinds of things in there. Now it's a little jumpy because my computer's having to do a whole bunch of things at once here. But hopefully you get the idea of how that might work. And so it renders it out, and then you stitch it all together. Well, it's kind of fun. Google Earth gives you a lot of other things. You've got, you can look at pictures, Leadville. They tell you all about the waste that's buried up the slope there. I tried to go up there, and they didn't let me go in. There's something called Google Earth Gallery, all kinds of interesting things you can look at all over the world and click on it. Many of these things are saved in KML files that you can bring into your application. So one of them that's interesting is shipwrecks. And you can go here off the coast of Italy and look down at, was that Costa Concordia? Was that the name of that one? Sightseeing, various things, interesting features, things that have been collected. These were airfields out west that were used for training during the Second World War. There's some of those arrows I was showing you earlier. Here's an old shipwreck. As best I can tell, nobody's figured out what this is. These are big features in Tibet. And they think it was probably some sort of training by the communist, Chinese communists, but I don't know. I wasn't able to determine or find any information about what they were. Okay, and so you can show the weather. Let's see what else. You can overlay images. You can take your own map and overlay it in Google Earth. If it's a geotiff or otherwise referenced, it will do it automatically, or you can reference it manually. So here's a historical map of the Gettysburg battleground that I've overlaid there in Pennsylvania over the battleground site. Map of Pakistan. Here's Katrina coming into New Orleans. I decided I would overlay a topographic map over a map with postal codes. That's what's checked here. So these little lines define the zip code areas around Alabama. And so here's the Auburn Quad. You can overlay it. Once you lay it, then you can look at it from an angle or perspective and see all of that together. Do a vertical exaggeration, and it will place your map. It will add the distortions associated with the terrain model that if you want it to. And notice again, using that, making it show three-dimensional buildings. The map is lying flat on the ground, so anything that sticks above the map will show up. So these trees and buildings are actually raised above the surface of the ground. Let's see, a whole bunch of other things you can do. These are things that Google Earth Pro will do. Now it's completely free. Here are some of the layers. I just copied some of them. You can click on any one of these things and it will show you all kinds of combinations, features that you might be interested in. Here's a land use map of Alabama. Again, this is brought in. It's what they call, a shape file. I'm not going to get into that now. But it's, again, easily available anywhere. And you can adjust the opacity, so I've turned it down a little bit so you can see through. And then click on any one of these and it will tell you the land use category here. So this purple area is a residential area in Birmingham. I'm assuming this is commercial down here. Yeah, commercial service. So you can go around and click on the map and see it. Here's a similar map for geology. And you can click on this is outside, west of Auburn. This is all in Google Earth. Import all of this. In Georgia, imported population data and told it I wanted to create a three-dimensional representation. So told it to color the counties different colors, random colors, but then create an elevation profile where the elevation of the county represents the population of that county. So you can see the area up around Atlanta standing out. Another thing you can do is you can use measuring tools of various sorts. So here I drew a circle, and it will tell you information, how many square feet within the circle. You can outline a building and then extrude it. Say, okay, I'm going to bring it up 20 feet and then calculate the volume of that building. You can do view shed analysis. So I said, okay, if I were standing right on top of Vulcan, the statue up in Birmingham, what can I see? And it's, you simply go down to, let's see, where is there, show view shed. And it asks you, well, if you place it on the ground, that's too low. You have to be up a little bit. So I said, okay, 17 meters. The Vulcan statue is 17 meters, and then the pedestal is 38, so that's a total of 55 meters. So, okay, I'm sitting on top of Vulcan's head. And relative to the ground. And everything in green indicates what I would see. Now it takes into consideration buildings that might be blocking the view or the trees. Notice areas where the trees block the view. And you can do it back out and do it for a greater distance. This is across, looking north across Birmingham, back out even further. And notice that from that point now, the tops of Oak Mountain will show up, but not the areas lower down, some of these areas. So anyway, it's an interesting exercise. What would you use that for? Well, if you're building something and you don't want to be, you want to see if you have a view of the ocean or not, you can do that. Or maybe you don't want to look at windmills, you can see where, put a view shed on the windmills and see where they're seen from or not. So it does have interesting applications. You can tour along a path, various sorts, and you can control various parameters. You can go down, you can go up, cycle around. Another thing you can do is you can take a database with locational information. So here are people from Ollie. I did this a couple of years ago. And import it. This is just an Excel file, a CSV. It will batch geocode those things, and it will identify location for everybody, where you are. And you can click on it, and it will identify, everything in that database about you. You can find latitude and longitude coordinates, and I'm not going to get into how you would go about do that, but for each one of these individuals in Ollie, then now I know the latitude and the longitude. Go back, put that back into Google Earth, and say, okay, what is the distance between that individual and, at that time we were meeting up the Clarion. And complicated formula, never mind about that. And so I said, okay, if you're within 1 mile, I want it to be one category, 2 miles, second category, 3 miles, third category, and so on. And so figure all of that out, and now you're all identified by a symbol associated with which mile radius you're within. And then you can, again, click on a feature and identify. I can create these circles associated with those 1 mile interval radius. And then Google Earth will tell you how many occurrences happen within each one of these rings. You can calculate an average distance of all these people from the central location. And let's see what else. You can color all this stuff with different colors, project it all. One other thing I was going to show you, there's been a lot of talk about global warming and sea level rising. Or you could go to a place like New York City in Google Earth, create a polygon around Manhattan, and say, okay, I want to raise that polygon, and I want to raise it, what was it, 2 meters? Yeah, that was the, and then associate that, 2 meters. And then say, use the three-dimensional view of the buildings and see what New York would look like. And essentially what you're doing is calculating what if the sea level were to rise by that amount. And colored it blue. And that's what New York City would look like if some of the forecasts for climate change actually occur. So I know I've gone through a whole bunch of stuff in a big hurry here. Basically wanted to just kind of give you a flavor or a taste of some of the things that you can do with GIS, with Google Earth. And, you know, it's a real interesting kind of thing to get into and get involved in. Okay, I think that was the end I had. All right. So, end of the course. Appreciate you attending. And see if you have any questions or comments. Yes.
How much memory do you need in your computer to use these things?
I don't have anything special. I'm just using my desktop. And I forget what I have, you know, a couple of, are the terabytes now? I don't know. Yeah, Dwayne.
If you download the GE Pro, will it automatically remove the garden variety GE that you already have?
It should be a simple upgrade, yeah. Mm-hmm.
So, I mean, would you have both programs after the download? Or?
I don't think so. I think it probably replaces, because it does everything that the regular Google Earth does, yeah. And you wouldn't need them both. It's really a simple process. And Google Earth Pro has a lot of nice features, including, you know, some of this is GIS capability type stuff. Now, it doesn't do everything GIS does, QGIS, but nevertheless, it does do quite a bit. Okay, that's it. Thank you.